Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on OpenMP implementation in Fortran. Now, in this tutorial, I'll be explaining to you guys about the if clause available in OpenMP. Now, just like how regular decision-making statements are available in regular Fortran, okay, some decision-making statements are available in OpenMP libraries. Okay, now these decision-making statements are helpful to decide to decide the outcome of the parallel outcome of the OpenMP directives and blocks and commands available while using OpenMP stuff. Okay, now in this tutorial we'll be looking at the if construct available in OpenMP. First of all, uh, what does an if clause does over here? Let me explain that. So, suppose if we write an if block along with if clause along with any parallel OpenMP parallel directive, like let's say like single or a barrier, or let's say a critical block or some master or something like that. What happens is as follows: we'll check whether that particular condition that we specified inside the if clause is satisfied or not. If yes, if that condition is satisfied, then what will happen is that then that particular block will be executed as it is in the parallel mode. Okay, suppose you have a parallel block and you have an if statement. If the condition is satisfied, then the parallel block will be executed as it is. If not, then that will be executed serially, and most probably the master thread will be the one that executes the entire stuff in it's a given entire that particular block. Okay, that's as simple as it gets. Okay, if that condition is true, that block will be executed as per the directives. If not, that will be executed serially by a single thread, and that would be mostly your master thread. Okay, now with that being said, now let's run this program. Okay, I set the number of threads to be 2 for this program, and I set thread number to be -1. I'm setting this because I thought of explaining to you guys one of the interesting thing that happened when I was running this program. I set the number of threads for the OpenMP call over here, and then I have this statement OpenMP parallel, and I have this if statement over here, and I'm keeping all the variables to be default, none of the variables to be the variable sharing to be default for everything, and I'm sharing the keeping the thread number value to be private for each and every thread, and then I'm calling the thread number. I'm calling the get thread number function to get the thread number, and I'm printing the statement stating that if clause done by thread number, comma the thread number, and the parallel block ends. With that program being explained, now let's see what happens. Suppose if this condition is true, what will happen is that this entire block will be executed in parallel mode, and we'll have each thread printing out saying that if clause done with this particular thread number 1, the thread number 5, thread number 0, something like that, depending on the number of threads you give. On the other hand, if this condition is not satisfied, then only the master thread will be working, and it will print out something like if clause done by thread number 0 or thread number -1 or thread number -1, depending on how these two lines are executed, and I'll show you that. First, let's run this serially. So if we run the serial, compilation is over, building, and now executed. It says thread if clause done by thread number -1. Fairly simple, nothing complicated. It's just as simple as that. Now let's go to the interesting fun part. Now if I run this statement as it is using parallel loop, let's see what happens. Let me push the terminal up. Let me clear this up. Okay, now this shell script is a similar shell script that I used for all the execution so far, so it's nothing complicated. So if I just run this, it says if clause done by thread number 0. If clause done by thread number 0. Now you will be wondering, now since the number of threads is 2, okay, this if condition the condition inside this if condition is if clause is false, and as a consequence this entire thing is not being done parallelly. Okay, simple enough. Now why it should have been thread number this statement should have been if clause done by thread number -1, isn't it? But why are we getting 0? Well, that's because if this construct is false, I mean if the condition inside this if block is false, then what will happen is that these statements will be executed serially. I mean it will be executed by a single thread. That's about it. It will be executed by a single thread, and as a consequence, what will happen is that usually the master thread gets to do the job, and here the thread num function, the thread number value will be 0, because the OpenMP get thread number would be 0, because since master thread alone will be doing this part, the thread number will be 0. Hence this function will get the thread number to be 0 and assign it to thread number. And if you print it out, it will be print if clause done by thread number thread num, something like that. Okay. Now what I'm going to do is that I'm going to comment this line as it is, comment this line as well. Now if I comment this line, let's see what happens to the results. It says if clause done by thread number 0 again and again. Now this is strange. This time I commented out the thread number line function as it is. I mean I'm going to comment this line also, right? Then why am I getting still thread number to be 0? Well, the reason is because when we're initializing the private value, when we set the private separate copies for private thread num to each, and when you set private copies for thread num, okay, they are initialized to 0. They are initialized to 0, and as a consequence, even though this line did not get executed, we still get the if clause done by thread num to be 0. Now, one way to avoid this is by commenting on the line on the top and commenting on this line. I mean, including this line. It says the first private thread num, meaning the initial value of thread num will be taken as the value for all the copies of the threads and copies of the threads. Okay, for all copies of threads. So if I run this right now, it will say if clause done by thread number -1. Okay, just clearing that out. Okay. Now what I'll do is that if I just uncomment this line, if I uncomment this line and I run this, I'll get if clause done by thread 0, because when that happens, it doesn't matter what the value of thread number over here, the thread number gets overwritten by this function over here, and hence you get this value printed out. So just clearing this out, because when I ran this program first, I was getting a little confused. Like it should have been it should print as -1. I anticipated the results to be -1, but they were turning out to be 0. So I was just playing around. I found this out, and this is through by which I understood that only thread number 0 does. I mean the master thread alone does this loop. Okay, so I thought of letting you guys know, and this is actually a proof that only the master thread does this particular block because of this if clause. Okay, that's a particular proof that you guys can keep it. Now let's write a condition wherein bring up a case wherein this if statement is true. Now I said if the number of threads is 4, right? So let me put the number of threads to be 5. Remember, my system has 8 threads, so I can push it to 8, no question about it. It will work fine. So in your system, you might have your laptop or desktop, whatever it is, you just have to make sure these numbers match accordingly. Okay, that's not a big deal. So if I run this in shell script, I will say if clause done by thread 2 thread 1 304. Very good. It doesn't because of this, it doesn't matter if I put private or first private. It doesn't matter. Whatever be the case, the answer will be fine, because in both the cases they all will be overwritten by this statement over here. The thread number for each thread will be overwritten by this command. Hence the results, the statements would be consistent. Okay, and that's the end of today's that's the end of this tutorial. Okay, thank you guys for watching. Hope you guys understood this if concept very clearly. Okay, and that's all I have for you guys in this tutorial, and I'll see you guys around the next tutorial. Till then, take care. Bye.